There's a claim going around that local AI has finally caught up, that open models you run on your own machine are now good enough to replace the cloud for real work. It's a reasonable claim, and it's partly true. This video answers 5 questions. Has local AI actually caught up to the cloud? What can you realistically run on your own hardware? What is it good enough for, and what is it not? When is running it locally actually worth it? Is running it privately the same as running it securely? We'll take them in order, and by the end, you'll be able to answer, is local AI good enough for your own work, instead of in the abstract? Start with the benchmarks, because that's where the claim comes from. And on the numbers, it's largely accurate. On standardized knowledge tests, the gap between the best closed models and the best open weight ones has gone from large to nearly nothing in about 2 years. Open weight models now hold a majority of the positions on the public leaderboards. On general knowledge and on structured tasks like coding and math, local models have genuinely closed most of the distance. But the convergence is uneven, and that's the part the headline skips. The gap has closed on knowledge and structured work. It has not closed on the hardest things, long, multi-step autonomous tasks, genuinely novel reasoning, and the most demanding creative work. There, the large cloud models still lead. So, has local AI caught up? On many tasks, yes. On the hardest ones, not yet. Whether any of this is usable comes down to what your hardware can hold. So here's the technical core in plain terms. A model's size is measured in parameters, billions of them. At full precision, each parameter takes real memory, and a large model simply won't fit on a normal computer. The technique that makes local AI practical is quantization, storing those parameters at lower numerical precision, say 4 bits instead of 16, which shrinks the model substantially with only a small loss in quality. A useful rule of thumb, at 4-bit precision, a model needs roughly half a gigabyte of memory per billion parameters, plus overhead. So a 7 billion parameter model fits in around 5 gigabytes, a 32 billion one needs about 20, a 70 billion one over 40. The common file format you'll see is GGUF, and you'll keep seeing one label in particular, Q4_K_M. It's worth decoding that label because it's everywhere. The Q is quantization, the 4 is the number of bits per weight, 4 instead of the original 16. The K means it's a K-quant, which is the clever part. Rather than squeezing every weight equally, it keeps the most sensitive layers at higher precision and compresses the rest harder. And the M is medium, the balanced size between a smaller S and a larger L. In plain terms, Q4_K_M is the community's default sweet spot, about a quarter of the original size for only 1 to 3% quality loss. One counterintuitive rule worth knowing. For the same amount of memory, a larger model at lower precision usually beats a smaller model at higher precision. So the move is to run the biggest model your memory allows, then lower the precision, not the reverse. The practical upshot: a modern laptop comfortably runs small to mid-sized models. The very large open models still need serious hardware, a real GPU, not a thin laptop. Now the central question, given what you can run, what is it actually good enough for? The right frame is task fit, not raw capability. Bigger is not automatically better. For a narrow, well-defined task, a smaller model built for that kind of work often performs as well as a much larger one, and sometimes better than a larger, more general model. Capability and fit are different things. So, summarizing documents, extracting fields, classification, drafting routine text, answering questions about your own files, these sit well within reach of a small local model. Long, open-ended, multi-step work is where you still want the frontier. The durable question is never, what's the most powerful model? It's what's the smallest one that's good enough for this task. So you can run it, and it's good for real tasks. When is it actually worth running yourself? And what does it cost? Because free has an asterisk. For personal use, On a computer you already own, the honest answer is nearly free. Once the model is downloaded, the only running cost is electricity, a few cents an hour. No per-question fee, no meter. If you have a capable machine and you value privacy, the math is easy. One 2026 analysis put a high-end consumer graphics card at breaking even against a $200 a month cloud subscription in well under a year. The asterisk is this: the model is free, but capable hardware and your own time are not. To run the larger models well, you need real memory, a serious graphics card, not a thin laptop, and setup and upkeep take effort. So free holds for the everyday stuff on hardware you already have. It gets expensive when you have to buy hardware or pour in hours. And at the other end, if you're thinking about running a model to power an app or a whole team, not just yourself, the economics flip in a specific way. Self-hosting only beats paying a premium cloud provider once you're processing serious volume, very roughly, somewhere in the millions of tokens a month. Below that, and especially against the cheapest cloud models, paying per use is usually cheaper once you count the hardware sitting idle and the engineering time to keep it running. The rule most teams land on is simple: start in the cloud and move to your own hardware only when the volume clearly justifies it. Which points at the real reason to run things locally. It often isn't cost. It's privacy. Data that can't leave your machine, which for regulated or sensitive work is the entire point, plus predictable spending, working offline, and running models nobody else hosts. Cost is one input. For most people who choose local, it isn't the deciding one. One distinction that's easy to get wrong: running locally makes AI private. It does not automatically make it secure. Those are different properties. Two concrete risks. First, the model file itself. Some older model formats can execute code the moment they're loaded, a genuine attack vector, so it's worth preferring the safetensors format, which is data only and can't run code, and getting models from sources you trust. Second, prompt injection. A model can't reliably separate your instructions from instructions hidden inside the data it's processing. An agent reading a document that contains a hidden command may simply follow it. This is inherent to how these models work. It can't be patched out. And the risk grows with how much the agent is allowed to touch. Running things yourself gives you privacy. It also makes you responsible for the security a cloud provider used to handle, vetting what you run and limiting what an agent can reach. So, is local AI finally good enough? Now we can answer it properly. For everyday and structured tasks, summarizing, drafting, coding help, private document work, yes, on hardware most people already own. For long autonomous tasks and the hardest reasoning, not yet. The frontier still leads. Good enough was never one question. It's one per task. And the gap that remains is closing quickly. What's out of reach this year tends not to stay there.